Hi class, today we're going to learn how to use the quadratic formula to solve a quadratic equation. So just like factoring, you have to make sure that your equation is in standard form. So that's ax squared plus bx plus c equal to 0. So in other words, all of your terms have to be on one side of the equation, and the equation has to equal 0, and your terms have to be separated by pluses or minuses. So the quadratic formula is the formula that you see here in blue that I'm boxing off. So x is equal to negative b plus or minus the square root of b squared minus 4ac, and that entire numerator is over 2a. The a, the b, and the c comes from the equation in standard form, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So you're going to want to memorize the quadratic formula. You'll need it for future assessments. If you're a STEM major and need to take more math classes in the future, this is something that you will use often. So make sure you memorize that formula. So let's use it in the next example. So here I have x squared plus 5x minus 3 equal to 0. That is already in standard form because all of my terms are on the left, separated by pluses or minuses, and it's set equal to 0. So a is the coefficient of x squared, a is 1. B is the coefficient of x, so it is 5. And c is the constant, and that is negative 3. So notice that the sign will correspond with whatever is it's associated with in the standard form. So since we have minus 3, we considered c to be a negative number. So now we plug into the formula. The formula says to start with negative b. Since b is 5, we now must change it to a negative 5. So it's negative 5 plus or minus 5 squared minus 4 times 1 times negative 3 all over 2 times 1. So in the next line, we have to simplify what's inside the radical. So it's missing here for some reason. Let me just put that back in. So I have negative 5 plus or minus the square root of 25, and that becomes a plus 12 because in the previous line, we have a minus 4 and a negative 3. Two negatives make a positive. So we move on to the third line of this problem, which is x is equal to negative 5 plus or minus square root of 37 over 2. Since we cannot simplify the square root of 37, we consider this to be a solution, but it represents two different answers, negative 5 plus root 37 over 2 and negative 5 minus root 37 over 2. Okay, so let's move on. Here I have 2x squared minus 7x equals negative 1. In this example, your equation is not in standard form. So the first thing you need to do is add 1 to both sides. When I do that, I get my equation in standard form in line 2. That's 2x squared minus 7x plus 1 equals 0. So now we pick out our a, our b, and our c so that we can then plug it into the formula. So a is 2, the coefficient of x squared. B is negative 7, the coefficient of x. And c is 1, the constant. So now remember, our formula starts with negative b, but this time my b is a negative number. So when you plug it in, you have negative 7 in the start of your formula. Plus or minus the square root of negative 7 squared minus 4 times 2 times 1, so all over 2 times 2. In the next line, we want to simplify what's inside of the square root. So, and we also do the double negative 7 minus a negative 7 is a positive 7 plus or minus 49 minus 8. So we have to subtract the 49 and the 8 before we take the square root if we can. So in the last line, I have 7 plus or minus the square root of 41 over 4. So the square root of 41 cannot be simplified, so you can leave it as is. And again, this represents two solutions to the quadratic equation, 7 plus root 41 and over 4 and 7 minus root 41 over 4. So now you can try your homework for 14.3, where you're using the quadratic formula to solve an equation. Good luck.